Hello everyone, my name is Krishnendu Paul and I am from BuildTech Consultancy. I am making this video as a part of the final assignment of tall building design course from Skyfi Labs. The tall building design online video tutorials from Skyfi Labs was used to complete this project. So in this video we will learn to model this 23-story building in ETAB, and also we will learn how to design the structural element. Okay, so here as you can see in this figure, this is a building and here different stories have different floors. So basically in this total building there are 4 type of stories or floor plans. So here you see in story 1 to 8 the floor plan will be like this. Okay, the dimensions are given. In story 9 to 14 the floor plan will be like this, and from story 15 to story 19 the floor plan will be like this, and from 20 to 23rd this will be the floor plan. Also you can notice the loads which are different for the different floors. Okay, and there are different elements will be used which are columns and beams. The like columns will have these dimensions, beams will have these dimensions, and we will use M40 grade of concrete and HYSD 500 for the main rebar and mild 250 rebar as a stirrup, and slab will be of 150 millimeter thick and will be grade M40, and there will be auto cladding so that we can apply the wind load. And as the cladding will also have a self weight, so cladding load will be assumed as 0.2 kN per meter. And for wind load we will consider the location of the building will be in Bangalore. Okay, so let us start the modeling in ETAB. So if you open this ETAB you will see this interface. So here we have to start with a new model. So click on that. So it may take a little bit longer time depending on the speed of the processor. So here we have to use built-in settings. Okay, so here we can use this metric SI, and we are in India, so we will select Indian database, and we will use this IS 800 2007 for steel design code, and for concrete design we will select this IS 456. Okay, so click on OK. So here first thing is that we have to prepare the grid, because depending on the floor what we have seen in the beginning, we have to prepare the grid. Okay, so if you see the figures here, you can see the spacing between the beams, okay, are 6 meter in this direction and in this direction. So we have to make this grid like this. So there will be 1, 2, 3, 4 grids along this direction, and along this direction 1, 2, 3, 4 grids. Okay, and the spacing between the grids are 6 meter in each direction. So number of grid lines in X direction will be 4, number of grid lines in Y direction will be 4, and the spacing will be 6 meter. Okay, so enter 6 here, and here it is also 6 meter. Okay, and as you see in this figure it is 23 story, so we have to go to the custom story data. So then click on this edit story data. Here as you can see there are only 1, 2, 3, 4, 5 stories, so we have to add 19 more stories in this story data. So click on this portion, add a story, keep existing story heights. So as you can see this story height are 3 meter, and it is also mentioned, it should be mentioned in this figure. Anyway, it is not mentioned here, so let us consider this as 3 meter height. So click on this then add story, keep existing story heights. Now story heights will be 3 meter of the new story which will be added. Okay, and number of added stories will be, as it is 23 story and we have 5 stories here, so we'll add more 18 more stories. Okay, insert above story, so with that story which will be added, that will be added after story 4. Okay, so keep this as default. So wait for some time, it will be added. You can see the progress here. Okay, now as you can see, okay, we have to add one more story, as it is 23 story, so add one more story. Okay, click on OK. So 23 stories are there. Now as you can see in this figure, these story 1 to 8, these are similar, like similar plans will be there. So for story 1 to 8, they should be modeled as similar story. Okay, and one floor out of this 1 to 8 will be master story and others will be similar to that master story. Same thing is applicable for this 9 to 14th floor. So from 9 to 14th floor, one story will be master story and others will be similar to that master story. So same thing is applicable for this and this. Okay, so here as you can see, every stories are master story by default, so we have to change it. Okay, let us change it manually. So we have to change it all. All the stories should be no initially. Okay, so we have changed. Okay, now as you can see in this image, so story 1 to 8 will be similar, so make one story as a master story. So you can make any story here as a master story. So I am making this 8th floor as a master story. So now this story 1 to 8, 1 to 7 basically will be similar to this story 8. So we have to look at this column here, it is similar to, so we have to change these properties here. This 7th floor will be similar to story 8, like this story 8. Okay, okay, now in this figure, okay, in this figure you can see from story 9 to 14 this floor plan will be same, so we should make this 14th floor as the master story for the next part. Okay, so go to 14th floor, this floor, this is master story. Okay, now this below that 14th floor, every story will be similar to the 14th floor. So as we have made two master stories, so these two options will be available here. So for the second, this part and this part follow the same procedure. Okay, so I have changed all the properties like this image figure. Okay, now you can see here the total elevation, that is 69 meters. So on the roof of the 23rd floor, the height will be 69 meter. Okay, now let us click on OK. So then click on grid only. Okay, make sure it is, this option is selected, then click on OK. So it is created, the grid model or the grids are created for 23 stories. Okay, and you can see the spacing between the grids are 6 meters, 6 meters, 6 meter here in this direction, and this direction is x direction and this is y direction. So here in this direction the spacing between the grids are 6 meter. Now the first thing is we have to create the properties, like properties of material and section properties. So as you can see, we will be using M40 grade of concrete, HOSD 500, mild 250 rebar. Okay, so we have to create these material properties in this model. Okay, so here go to this define property, define options. Here you go to this material properties, and here you have to add this material or create this material. So we have to click on this add new material. So we are in India, so we'll go to the India, and material type is concrete, and it is Indian, and the grade of concrete is M40. So these options, this M40 property of this M40 is available in these items. Click on OK. Then these properties are automatically selected. Then click on OK. Then again we have to create this steel. So add new material. Then select here rebar and HOSD 500. Click on OK. So these things should not be changed. If you have specific property of specific steel, you can change it. Okay, then click on OK. Now add new material, then rebar will be same, but it will be mild steel 50. Click on OK. Click on OK. So 3 materials have been created. Now click on OK. Now the next thing is that we have to make these sections like 500 into 500, 550 into 550, 600 into 600 for the columns, and for beams these are the dimensions. Now here in this model we will create these different sections, and automatically these which section will be preferable for which member, that will be selected. Like we will be creating these 3 properties for the column. So whenever these sections will be required, this is automatically chosen by this tab. Okay, so we will create an auto list for the column and for the beam also. Okay, so the software automatically iterates this analysis and automatically choose the required property for the element. Okay, now so here you can see 550 column. So go to this define section properties, frame section, because this is the column and beams are the part of the frame. So we have to go to the frame section. So click on this. Now here you can get a lot of previous sections available. You can delete this also. So click on delete properties, and you can select by dragging. Okay, then delete selected frame sections. So these will be remaining by default. You cannot delete all these properties. So click on OK. Now go to this add new property. So here the columns are rectangular. Okay, so you can select this concrete rectangular, and then there are by default there are different type of shapes. That is, we have to select these rectangular sections. So here you can see you have to give the name of the element. That is, first is 500 into 500. So give it a name, column 500 cross 500. Okay, then the material will be M40 grade. Now this dimension should be changed, 500 into 500. Okay, now here you have to go to this option, modify and show rebar. Here, as we are making this section for the column, so we have to go select this option. Okay, column, here you can see this is column. Now here for the column reinforcement we want to use HOSD 500, and for tie bar or stirrup we will use mild steel 250. Now the cover for the column will be 40 millimeters, so you should not change this, and if you want to provide more cover, then you can change it. Okay, now click on OK. So then click on OK. So now we have to create this column, second column. So you can copy this column because that will be easy. Okay, so add copy of the property. So write the name 550 into 550. grade will be same. This is automatically selected because we have just copied this property. So these things should be changed. Okay, we should not bother about that because we have copied. Okay, click on OK. Now another 600 by 600, so add copy of the property. So you should select the column here and add copy of the property. So here column 600 into 600, and the dimensions should be changed 600 into 600. Okay, click on OK. Okay, now we have to provide this beam property. So we have to go to the add new property here for the different element, because column is one element and beam are different element. Behavior are different. That's why we have to add it from the beginning. Add new property. Then go to this. So give the name 500 into 300. Okay, so material will be M40. Now the depth is how much? 500, and width is 300. Okay, so here we have to go to this reinforcement. Now we have to select this beam because we are making the beam property. So go to this. So grade will be 500. Here mild steel. Now it will be 25 by IS 456. You can increase the cover also. Okay, click on OK. Okay, I hope we have selected this beam option, so it is okay. Now click on OK. So we have to create another two beams. So you can copy this beam property, add copy of the property here, and give the name, proper name, beam 550 into 350. So just change this 550 into 350. So do not change this option because these are by default selected. Then again for the third property, give the name 600 into 400 and change it here. Okay, click on OK. Now we want to instruct this ETAB to choose required property automatically for the every beam element. Okay, so we have to create another property. So for beam, to auto select the beam element, and we have to create auto column selection property. So click on add new property, and then here you can see there is auto select list. So click on this. So here we have to select the concrete. So we have we will be creating auto beam property. So give it a name, auto beam property. Okay, select the beam, okay, by dragging. So click on add, click on OK. Okay, then again add new property, auto select list, auto column. Okay, auto column list or selection. Okay, then here here select concrete, then select the column sections, click on OK. Okay, so these things are created, auto beam property and auto column property. You can change the name also. Okay, no issues. Click on OK. Now we have to define the slab element. Okay, so for slab element you can go to the properties, then slab sections. Okay, define section properties and then slab sections. So here click on add new property, then slab, our slab is 150 millimeter, so slab 150, and change its dimensions 150, and change the material also. Here it will be M40 grade of concrete. Okay, so okay, then click on OK. So the materials which are used in this 23-story building, that is selected. Okay, now we have to model this total building as per the plan, floor plan. Okay, now we will create this column and beam. So for story 1 to 8, the floor will be same, so there will be columns in every grid joint. So go to this quick draw column, and before that, as we are going to model this story 1 to 8, so we have to be in story 1 to 8. Okay, so click on escape. So by using this option, I am going to any story between story 1 to 8. Now I will be selecting these similar stories. Okay, so whatever I will draw, it will be drawn in this story 1 to 8. Okay, so now click on quick draw beam, column. Then here property will be auto column list. Okay, so here just drag this total portion, automatically the column will be drawn on the similar stories, all the stories. Okay, now similarly draw the beam by selecting quick draw beam, then select here property. Okay, property, so here auto beam property, just drag this, so automatically beam will be added on the columns. Okay, now we have to draw this second part, that is 9 to 14. Okay, so for 9 to 14 we have to go to any floor between 9 to 14. So enter escape and go to the upper stories 9 to 40. So it is 8, 9. So you can be in on any floor and select these similar stories. Okay, then we will be drawing these model floor plans. So column will be placed here in these portions. So select the portion, first select these quick draw columns, then auto column list, and then select the portion, these portions. Okay, so column is placed on these portions. Now select these portions, so except this point and this point, column will be placed. So now then quick draw beam, again select these portions, and again from this side, okay, select these portions. Okay, so beams are drawn on above the column. Now we have to draw these floor plans on story 15 to 19. So here go to this story 15 to 19. So then similar story again, then quick draw column, then auto column list. Then here you see these are the position of the columns. So select the portion like this, floor plans. Okay, here also select these portions. So columns are placed in these locations. Now quick draw beams, same thing should be done here. Okay, so I think it is clear to you. Now third part is for 20 to 23rd story. So go to the above stories. Okay, here you see this portion is occupied by the floors. So select these quick draw columns, then select these portions. There are 6 columns only, and quick draw beam, auto beam property, then select these portions. So this is not a beam, Okay, this is also not a beam, so don't be confused. Okay, then so we have drawn beams and columns. So now we have to draw the slabs. So similarly, uh, go to the each floor sections and draw the slab. Okay, so let us go to this between 1 and this 8 story. So then click on the this quick draw slab. Okay, so select the slab objective. So select these portions, automatically slab will be added in between these floors, and as the similar option is activated, so the slabs will be added on this portion. Similarly, go to the other floors and complete this addition of the slab. I am fast forwarding this part. So we have completed this addition of the slabs in all the stories. Now we have to add the cladding. Okay, so go to this draw, then auto draw cladding, use floors. So the option will use the floor levels to draw the cladding. So click on OK. So as you see, the claddings are added on every sides on the outer periphery of the buildings. So now next part is we have to add the loads. Okay, so we will apply the loads. We will assign the support condition and the loads. So loads will be dead load, live load, and wind load and cladding load. So first thing we have to do is assigning the support. So go to the base. So click on this plan view, go to this option, then base 0. Here you can see the supports or the grids join. So we have to assign the fixed support for this joint. As all stories are selected, so we have to go to the one story, then again do the same procedure from the beginning. So click on escape, then assign select all the joints again, then go to this assign, then joints, then restraints, then fixed support. Okay, click on apply, then click on OK. So fixed support has been assigned on the every joints at the 0 level. Okay, so now we have to assign the dead load. Before assigning the loads, we have to create the load patterns for the structures. So go to the define option, go to the load patterns. Here you can see the dead load and live load patterns are already available by default. So we have to create load pattern for wind load. So give a name of wind load, then type of the load will be wind, then select this relevant IS code, that is IS 875, then add new load. Okay, now click on this wind load, then modify lateral loads, because the loads wind loads are lateral loads. So now here in this windows you can see we have to change some values which are already there by default. So wind speed, so as the location of the building is Bangalore, so you can refer to the IS code. So here I have opened this IS code. So this is the IS 875 part 3. So you can see this figure. So here the city is Bangalore. So for this color you can go to this legend map. So here basic wind speed is 33 meter per second. So we have to put this 33 meter per second here. So terrain category. For terrain category we can refer to the IS code again. So for terrain category you can see below the map there is 4 different category according to new IS 875. So you can read these details of these categories. So as the city is Bangalore, so there are closely spaced structures, so we can select this category 3 and you can read it in details. So select 3. Then importance factor, for again importance factor is also mentioned in this code. So here if you see this importance factor for cyclonic region, so here you can see different type of structures are there, okay, and the importance factor are different. So we can select all other structures here, and if your structure is different, then you can select higher importance factor, okay. So importance factor will be 1 here, okay. Then risk coefficient, so for this also here you can refer to this code. So K1 factor will be available in this risk coefficient. This is K1 factor, okay. So as the speed is 33 and we are selecting the all general buildings and structures, so the speed K1 will be equal to 1, okay. If the speed is different, then you have to select other values for different class of structure. Then so in risk coefficient will be 1. Then topography factors, so for that you can go to these topography factors here. The K3 is factor, so here you can read this point 6.3.3.1. so if the effect of topography shall be significant at a site when an upwind slope is more than about 3%, and below that the K3 may be taken to be equal to 1. So up to 3 degree it is 1, and above 3 degree it will be varying from 1 to 1.36, okay. So you can read these in details and you can select the required values for required location, okay, and required topography. So here we will select 1. So other values keep it as default. So then click on OK. So then again click on OK. Okay. So now we have to apply the dead loads. So as we can see, the dead loads are same all floors, and dead loads are applied on the floors. So we have to select the floors. So go to the upper story and then select the panels, and before that you have to ensure that this is selected, all stories is selected. So select the floors, so all the floors will be selected, and if on the above story there are no floors, it will not be selected. So thus we can select all the floors. Now go to the assign, then frame load, or you can go to the uniform. Here is shell loads, okay, because we have selected shells here. So go to the shell loads, uniform, okay. So type 2 and click on apply, click on OK. So 2 kN per meter square load is applied on all floors. Now we have to apply the live load. So live load is different for different floors. So from 1 to 8 story, the live load is 5 kN per meter square, okay. So we have to go to the similar story, and we have to be in between 1 and 8 floor. Then again select these floors, okay. Then go to this assign, then shell loads, uniform. So here you have to select the live load, okay, and live load here it is 5 kN per meter square. So click on apply, okay. So in this way you have to cover all the heights, all the floors on the above stories, okay. Go to this upper story, select the panels or the shells. So 42 shells have been selected. Go to assign, shell loads, uniform, then the loads is 4.5 kN per meter square. So 4.5, then live, apply, okay. So in this way we can complete the other loads.
So in this we have covered all the live loads in the same manner. Now we have to apply the cladding load. So cladding load will be applied on the outer beams, because cladding are placed on the outer beams. So we have to go to this each category of these floors, and we have to see the we have to select the peripheral beam to apply the cladding load. So go to this bottom story, and you can directly go to this bottom story or story 1 by this option plan, then this story 1 apply. Okay, so here you select this beams only, the peripheral beams only, to apply the cladding load on this peripheral beam. So we have to be sure that this similar stories is selected, because claddings are available on all the floors in this category. So here you can check 88 frames have been selected. So then assign then this frame load, because we have selected the frame element. So frame load, here or frame load, then distributed load. So as we can see, cladding load is 0.2 kilonewton per meter, so we have to keep 0.2 here. Okay, uniform load, then click on apply. Okay, do not change the other values. So click on apply, click on OK. So again in the same manner we have to go to this story 9 to floor 14. So go to this 9 to 14. So I'm going to 11 story. So I'm checking that all stories are selected here. Okay, all stories are similar stories are selected here. So again selecting these peripheral beams on which the claddings are there. Okay, so I have selected 72 frames. So again in the same manner we have to assign the frame loads distributed, and then again 0.2 kilonewton per meter. Click on apply, click on OK. So in the same manner we will apply the cladding load on the upper stories. So we have applied all the cladding loads on the above stories. So then we have to apply the wind load. Okay, so wind load will be applied on the claddings from the lateral direction. So whenever the wind will hit the cladding, there the wind load will be applied. Okay, so if there is no cladding on any story, then there will be no loads. So it will be clear if you see the procedures. So here we can go to this first category of the floors. So click on apply. Okay, so here all the, if you see this figure, okay, so if you see this grid line, then on this grid line this cladding will be subjected to this wind load. Now and then there is no cladding in this portion, so it will be subjected to this portion. So we have to select this grid line and then also this grid line. Okay, and then there is no cladding if the wind is coming from this direction, left to right. Okay, so we have to select this grid line and this grid line to get the required surface of the cladding. So let us go to this elevation part. So we are going to elevation A. So we will see this face of the building. Okay, so apply and OK. Here you can see and here these loads are showing here, so you can just click on undeformed shape. So the loads will not be shown here. So then click on these shells. Okay, so before that click on these all stories. So every shells will be selected. So here wind is coming from this direction, okay, from this direction. So the coefficient will be selected from the IS code. So how can we do this? So go to this assign, then this shell load here, then we have to see the wind pressure coefficient that is available in IS 875 part 3. So for that, go to this external pressure coefficient CPV. Okay, here you have to categorize this this building based on this building height by height ratio and building plan ratio. Okay, so here total height of our structure is 69 meter and width is, as you can see the plan, this is 6 meter, this is 6 meter, this is 6 meter, so it's 18 meters. So this width or the length of the plan will be 18 and height is 69. So based on this we have to categorize this building. So as you find these values h by w, and then you can see that the category will be in this portion. Okay, and then you have to find the L by W ratio, so it will be in this portion. You can find this. So we have to use this part to use the pressure coefficient. So as the wind is acting at theta degree, so theta may be 0 degree if wind is acting perpendicularly on this face A, and it can act in this from this direction from top to bottom here like this. So in that case the theta will be 90 degree. So you can interpolate in between this 0 and 90 degree. So we will assume that wind will be acting perpendicularly on this face A. So the angle will be 0 degree. So this value should be selected. Okay. Now on which face which value should be selected, that should be understood. Okay, so on face A you can see this A, B, C, D. So in our case this A face, what we have selected, that is A face. So opposite of that face will be B and other are C and D. So for A the coefficient will be 0.8. okay, so it will be 0.8. So it is windward direction because wind is acting in this direction. Okay, so click on apply. Now we have to select this face. So for that we have to go to this, let us see which grid will be for that. So we have to select this B grid. So again go to elevation, then grid B, then apply, then OK. So these shells will be the windward face. So for that same thing should be done here. Shell load, wind pressure coefficient should be 0.8, windward direction. So click on apply and OK. And then again go to this plan view for better understanding of this. Okay, so here we have applied this wind on this face. So this face, that means grid lines along this D will be this this is B. Okay, so our D grid will be face B. Okay, so for face B the coefficient is minus 0.25. So that should be applied. So we have to select this B face, that means in our case it is D face. So go to this elevation, so go to this D, click on apply, click on OK. So again go to this figure. So we are now applying the wind from this direction, or we are considering, better to say, we are considering these directions. Okay, but wind is acting from the left to right. So here this face is selected. So you can see wind is also acting in this grid, in this face. So we have to select this grid also. Okay, so that means we have to select the grid C. Okay, here also the grids, on this grid C, the panels or the cladding will be subjected to this wind force. Okay, so we have to select this D grid and this C grid. Okay, so here we have selected this D grid. So select all the shells. You can select, you can see these 41 shells selected. Then all stories are selected. Then assign, then shell loads, then wind pressure coefficient, and here it is how much? There is minus 0.25. Okay, so minus 0.25, right? So it will be leeward direction because wind is acting from left to right. So for that, that opposite face will be leeward directions. Okay, click on apply, click on OK. Now again we have to select this C grid. Okay, C, apply, OK. So select these panels or the claddings, then again assign, then this shell load, wind pressure coefficient, the same thing is applied here. Okay, now we have to go to this, we have to apply the wind pressure coefficient for C and D. So for both okay, for C and D, which are parallel to the direction of the wind, so for that the wind pressure coefficient is minus 0.8. Okay, so that means this space means this space. So in this space, this grid should be selected also. Okay, and this grid also should be selected, and this grid should be selected. So we will select these what these let us is a plan. So we have to select these 4 grid and 3 grid. Okay, as well as grid 1 and grid 2 for these directions. So on all the grids the coefficient will be same, that is this minus 0.8. Okay, so 4 3 2 1, so elevation 4 3 2 1. So you can go one by one. 4, okay, the frames are selected. Now click on escape. So do it carefully, shell should be selected. So here, and you can go to the elevation again to select all the values at the same time. So this was 4 elevation, so then 3. Okay, do it carefully. Okay, then go to this elevation 2. Okay, then go to this elevation 1. Then go to assign and go to shell load, wind pressure minus 0.8. Click on this leeward should be selected, then apply. Okay, then go to this plan. So you can see the wind directions are correct. Okay, so you can check it from this plan. So now all the loads has been applied, so now we can analyze our structure. So go to this analyze and run analysis. So it may take time depending on the processor speed. So the analysis part is complete. So here in this displacement in this window, if we select any point, it will show you the displacement of different points. And in this window you can see the bending moment diagram and shear force diagram in the display menu. Okay, so here you can go to this force and stress diagram, and then frame this element, and then you can go to this moment 33 to see the moment diagram. You can apply, so you can see the bending moment diagram, and if you select shear 2 you can see the shear force diagram for the structural element. Next is we have to design the member. Okay, so to design the member or the beam and column, we have to go to this design, then concrete frame design, then this. But before that we have to go to this revise preference to see what are the codes which are assigned. So here we can see IS 456 2000 is applied, so click on OK. Then go to this design, concrete frame design, then start design and check. Okay, so it will automatically design this structure for you, and in the designing process it will select the first smaller section for beam and column, and if it fails then it will automatically ask you to reiterate, and automatically software will reiterate the analysis or the designing. Here you can see optimizing concrete auto select properties. So it is optimizing the concrete, and that means these beam and columns. So automatically it will give you the best result. So you can see analysis and design section differ for 7 concrete frames. So that means 7 concrete frames, that means it may be beam and column, so they have been failed. So it wants to do we want to reiterate analysis and design? So it is asking permission to reiterate for finding the best solutions. So click on yes, and then at the end it will give you the best result by assigning a better section. Okay, so then we have to go to the detailing part. So as it is ETAB 18.1.1, so the detailing is not available here. So detailing tool is extra, and it is not coming with this ETAB inbuilt. So we can go to this detailing software for ETAB, and we can import this file of this analysis, and automatically the software will prepare the design, that means reinforcement and all this. So the designing is complete. Here you can see for every elements the reinforcement is given, top and bottom area of reinforcement is given. So this file can be imported to this ETAB detailing software for getting the detailing part. So as it is 18 version, so it is not inbuilt with this 18 version, so we have to use the detailing software by closing this ETAB, and we can get the report and all these required values as a format of table in this report part. We can get the total project report from this option report, and if you click on this, so it will automatically prepare the report for you. So it is taking time as this machine is very slow. So in this way we can prepare the tall building and apply the dead load, live load and wind load. Thank you for watching.